So today I am going to discuss with you these three topics, which the networking fundamentals, networking types and topologies, and network models. So what is networking fundamentals? So networking fundamentals is a set of computers connected together for the purpose of sharing resources. Here's are the example. Then connection between computers and network are made using physical wires or cables. Through network connection, computers are able to share files, internet access, printers, etc. But nowadays, it can be connected using wireless means, using radio waves or infrared signals. And here are the components of the network. So what is the component of the networks? Computers are connected through either Ethernet cables or through wireless cables. So first we have the end devices. What are these end devices? So end devices are the computing devices that interconnect with the use of IP address. It is a unique address of every computers. Now, for example, we have laptop, personal computers, printers, smartphone, camera, etc. So let's open this is packet tracers. So under these end devices, so we have a PC, we have laptops, we have servers, we have printers, we have IP phone, voice device, phone, TV, tablet, and etc. And the next, we have intermediary devices. What are these intermediary devices? These devices that connect together on a computer network. So examples are this network access device, these hubs, switches, and wireless access point. Secondly, we have interworking devices, which is the routers. Thirdly, we have communication servers and modems. Fourth, we have security devices or firewalls. So let's open this Cisco packet tracers. So what are the samples of these intermediary devices? We have routers, we have switches, we have hubs, wireless devices, the securities or firewall, and this one emulation. Alright, so let's go back to the these examples of the commonly used network devices. Now we have these hubs which connect multiple computers together and make them perform as one. Then we have the switches, is a device that connect devices together on a network. Here's the example. Then we have routers, the small electronic devices that join multiple computers network together via either wired or wireless connection. Here's the example. The network card is also known as the interface card. It's a hardware devices that connect computers with a network. Here is our example. Then lastly, the modem is a device or program that enables computer to transmit the data over, for example, this telephone or cable line. So application that uses a network. So we have examples. We have games, we have database, email, video conferencing, file transfer protocol. Then these are our second topic, the network type and topology. What is network type and topology? So it discusses the three basic type of network. So we have this LAN, or what we call the local area network. We have WAN, or the wide area network, and we have MAN, the metropolitan area network. So let's start with local area network. So how this happens? What is local area network? This is an individual network that usually spans within a single area within the building or runs inside the offices. So the common LAN devices are switches, hubs, and routers. So for example of this, here is the example of LAN connection. As you can see, there are only one hub switches, and all of the end devices are interconnected in a one hubs or switches. Now let's see, for example, in the Cisco packet traces. Let's make an example. For example, we're gonna choose the end devices. Of course, we have PC. We got 3 PCs. Three pieces. Here are the sample. Now let's get the intermediary devices, or let's choose the routers. Choose the routers. So let's put the routers at the center, then choose the appropriate cable. Alright, we run out of some ports. So here are the examples of local area network. So one routers, these 2 pieces, for example, these 2 pieces have different IP address. Why? It's because when 2 pieces have the same IP address, they have difficulties in locating each other. So here are second topic. We have wide area network. So what is this wide area network? That is a connection between 2 or more LANs over a potential large geographic area. So often one particular node on a LAN is set up to serve as a gateway to handle all communication going between network called this inter-networking. So here are the examples of one network. So there's 3 computers are connected with each other. And then we have the right side, we have these 5 computers that also connected with each other. So when we connect 2 LAN network, so it will become a one network. So here are the examples. So as you can see, we already made our local area network when we discussed the LAN network. Then the other, we have also 2 second local area network. So when we connect these 2, so here they become our one network. So here is the example of the one network. So as I said earlier, these computers have different IP address so that they can locate each other immediately. Now let's proceed to the next one. So we have the MAN, or Metropolitan Area Network. So what is this Metropolitan Area Network? So it is usually interconnect a number of LANs using a high capacity backbone technology such as fiber optical links, and provide uplink service to one and the internet. So MAN's coverage can span between cities. Here are the examples. So we have this local area network, we have local area network, local area network. So when you connect these 3 LANs, it become our wide area network. Then when we connect this wide area network into this what we call this one, this central NVR, which is the backbone technology of our network connection, they will call it as a MAN connection, or Metropolitan Area Network. So here I'm gonna walk you through on how to configure IP address on different PCs so that every IP address should be unique. So for example, we click this PC0, so go to config, then change this fast internet, then its IP address, for example 1 92.168.0.1, and then just click enter for the subnet mask, and then another one, fast internet. Then so since the last digit of our IP address for the PC is 0, so let's is 1, so let's put this 192.168.0.2. alright, just for getting the subnet mask, just only click or touch the enter on the keyboard. Then the PC3, it's fast internet, 192.168.0.3. alright, enter. And the other one, fast internet 0, 192.168.0.4. so enter. So they already have this unique address. So let's configure also for this router. So router, just click 000, serial 00, then 192.168.1.1, just enter for the submask. Then the other one, config, then serial 000, 192.168.1. the last digit that we have put on the first router is 1, so we're going to put this 2, then enter for the subnet mask. So that's all in all. That's all on how to configure IP address on different PCs and routers. Now, so let's proceed to the next topics. We have this client-server model. Alright, so what is this client-server model? It is a relationship between clients and server. Server is known as the client-server model. So we have the server. What do you mean by server? Server have software installed that enable them to provide information and services like email or web pages to other hosts or a network. Then you have this client. The client have also a software installed that enables them to request. So we have to take note the word request from the client, and server is to provide information, client is to request and display the information obtained from the server. Alright, so here are the examples. So in a computer, client can be, it's either a computer hardware or software that accesses a service from a server. Then the server also is a computer that provides services to other computer known as clients. So here's the example of a client-server model, as you can see. So the thing that is in between the clients and the server is called the internet or the network. So as you can see, that server is in the right side and the client is in the left side. So this server provides information, as I said earlier, it provides information to clients, and this client has a software that request and display information from the server. So next one, we have this network design and topology. So what is this network design and topology? It is a network or arrangement of the computer in a network. So first thing we have this bus topology. So what is this bus topology? Bus topology is a network topology in which every network device is connected in a single cable. So as you can see in our examples, we have these 6 laptops that are connected. They are connected in a single cable. Then the next one is we have this ring topology. What is this ring topology? The ring topology is a topology that form a ring each computer is connected to one another computer with the last one connected to the first. So as you can see in our example, so we have 6 PCs devices, we have 6 end devices, and they are connected with each other. This device 1 connected to device 2, device 2 connected to device 3, device 3 connected to device 4, device 4 connected to device 5, device 5 connected to device 6. This last devices is connected to the first devices, which is the device 1. Then we have the star topology. What do you mean with the star topology? Star topology is a type of topology that all computers are connected in a single hub. Why? As you can see in our examples, the 5 PCs are connected in a single hub. It's a single hub to make them as one. Alright, then network protocols and communications. So we have network protocols and communications. So what is this? So protocols. What do you mean by protocols? So protocol are the rules that govern communication made up of a group of related protocols that are necessary to communicate via electronic means. And we have this network protocol. Describe process such as format or structure of the message. The process by which networking devices share information about pathway with other networks. Next, we have mostly used protocols. Nowadays, we have the Hypertext Transfer Protocol, or HTTP, the Transmission Control Protocol, Internetwork Protocol, and multiple protocols. So we have we have this encapsulation and decapsulations. So let's talk about what are the difference between this encapsulation and decapsulations. When you say encapsulation, it's a process to hide or protect process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. Now we have this decapsulation. It is an inverse of the encapsulation process. So encapsulation, of course, is a process of taking data from a protocol and translating it into another protocol so that the data can continue across the network. Right. The next, we have this network model. So this last topic that we are going to discuss is this network model. So what do we remember the network models? So we have we will tackle these protocols and reference model. So what do you mean by protocol model? So this protocol model provide a model that is closely equivalent to the structure of a certain protocols. Then we have reference model, provide a common reference for maintaining consistency within all type of network protocol and services. So this reference models is maintaining the consistency within all the types of protocols. Then this protocol models is closely equivalent to the structure of a certain protocols. Now we have the network model. What is this network model? Network model is a set of network layers and how they interact. Then the following are the most important and well-known network models. So we have OSI models, or what we call it is an Open System Interconnect. So this system is the breakdown network function. This is the most popular type of internetwork reference models and consists of 7 layers. So those 7 layers we're going to topic onwards. Then we have this TCP/IP models, which is called the Transmission Control Protocol or Internet Protocol. It's also known as the DoD, or Department of Defense. So TCP/IP model is a protocol that is used in the internet. So okay, so let's talk about the OSI model. As I said earlier, that OSI model have 7 different layers. So the first one, or the 7th layer of the OSI model is this application layer. So it is the topmost of the OSI layer, and it provides a means for the user to interact within the software application. Then we have these presentation layers. The sixth layer of the OSI model provides proper common data format that is sent across application layer. Then we have this fifth layer of the OSI model, decision layer. Decision layer establishes, manage, and terminate connection between application. Then the fourth layer, which is the transport layer, defines services to segment, transfer, and reassemble data communication between the end devices. Then we have this the third layer of the OSI model, network layer. It provides the exchange the individual pieces of data over a network. Then the second layer is this data link layer, provide method for exchanging data over a common media. Then the last one, the last layer, or the first layer of the OSI model, we have this physical layer. It describes the mechanical, electrical, functional, and procedural means to active, maintain, and deactivate physical connection for bit transmission and to and from a network devices. So next models, we have this, the TCP/IP model, or this transmission control protocol models, transmission control protocol, or IP, or internet protocol model. The fourth layer of this model, this TCP/IP model, is this application layer. So what is application layer? It is the layer represent data to the user plus encoding and dialogue control. The third layer is the transport layer. We have support communication across diverse network. Then the second layer, we have this internet layer, determine the best path through the network. And the first layer is this network access control, the hardware, devices, and media that make up the network. So as you can see that the TCP/IP model only have 4 layers. So why? Let's going to continue later. So what do we mean this protocol data unit, or PDU? It is the form that a piece of data takes at any layer at each stage of the process. So we have data, segments, packets, frames, and bits. Data is a general term for PDU, or protocol data unit, used in the application layer. The segment used in transport layer, PDU. Packets, internet network layer, protocol data unit. Frames, network access layer, protocol data unit. And bits, a protocol data unit used when physically transmitting data over a medium. So OSI model versus TCP model comparison. So we're going to compare those two models. What are the difference and what are the same attitude of these two models. First, the OSI lost out to TCP/IP as the protocol suite of the internet. Secondly, the TCP/IP is mapped to the OSI model. The TCP/IP is the protocol used today, but OSI model is often used to describe network communication. So here are the examples. As you can see, the 7 layer of the OSI model and the 4 layers of the TCP/IP model. So what can you see? What is the difference of these models? So the application model, the application layer of the TCP/IP is consisting of the application, presentation, and session layer of the OSI model. So as you can see that these 3 layers, this application layer, presentation layer, and session layers, consist only one application layer in the TCP/IP layer. Then we have both layer have different equivalent transport layer. As you can see, transport layer of the TCP/IP model and the transport layer of the OSI model. they are equivalent. And of course, we have network layer, internet layer. In network layer in the OSI model, and network layer in internet layer in TCP/IP, they are equivalent. And the last one is this network access layer. So network access layer of the TCP/IP model is equivalent to the data link layer and physical layer of the OSI model. Then the last one is the network access layer, TCP/IP, and that's what I said earlier. Alright, those let's proceed to another presentation. Alright, for the next part, the part 2 of our discussion, so I'm going to walk you through on how to convert a network address to binary, and how to convert a prefix length to subnet mask and vice versa. Identify the 3 types of addresses: network, broadcast, and gateway address. So in this video, I'm going to walk you through on how to get all of them. So I'll prepare this format to get the binary. So since then that in the number 5 and number 9, we have to calculate, or we're going to convert this network address. This 192.84 and 235.0, and this 205.36.72.56. we are going to convert it into binary. So what thing that we're going to do? Of course, I'm gonna write this first, this number 5, before I'm going to continue to answer this 1, 2, and the other part. So I'm going to convert this first, this 192, and then we have 84, we have 235, and then we have 0, and the other one we have this 205, then 36, then we have 72, and the last one is this 56. So in order to solve them, so I'm going to put some 1, then 2, 4, I'm sorry, this 2, 2 times 2, 4, 4 times 4, we have 4 plus 4, we have 8, 8 plus 8, we have 16, 16 plus 16, we have 32, 32 plus 32, we have 64, 64 plus 64, we have 128. Then we have to solve this. We have to solve this number, this binary number, into 192. Since then, the only thing that we can put on that is the 0 and 1, because that 0 and 1 is only the numbers that a computer able to read. So here we have 92. So this 92 is composed of this 1, then 1, and the rest would be 0, 0, 0, 0, 0, 0. So how I come up with that with this answer? So it's going to add these two numbers. When we're going to add these two numbers, is 128 plus 64 is equivalent to 192. Then we have this 84. 84 is 0. There's 1. There's 0. 0 dash 1 dash 0 0 10 dash 1 dash 0 then dash 0. So this, so we're going to, if you're going to add the 64 plus 16 plus 4 is equivalent to 84. For example, 64 plus 16 is 70, it's 80. 80 plus 4 is equal to 84. Then the next one, we have this 235. Okay, 1 dash 1 dash 1 dash 0 dash 1 dash 0 1 1. Alright, so if you're going to add all of these ones, is equivalent to 235, and then this 0 is equivalent to 0 0 0 0 0 0 0 then 0. So therefore the answer for this number 5 is this one. So 1 1 0 0 0 0 0 0, then 0 1 0 1 0 1 0 1 0 0, then 1 1 1 1 0 1 0 1 1. Let's put it into number 5. So 1 1 1 0. I'm gonna make it a little. Alright, number 5, we have 1 1 0 0 0 0. It's it should be 6 zeros. 1 2 3 4 5 6. Then we have this 0 1 0 1 0 1 0 0, and this 235 is 1 1 1 0 1 0 1 0 1 1. It's going to count it 1 2 3 4 5 6 7 8 10 3 1 1 2 3 0 1 0 1 1. So here it's 1 2 3 4 5 6 7 7 8 bits. Then the last one is we have 8 zeros. 1 2 3 4 5 6 7 8. So we have 8 zeros. Then the next one, which is the number 9, is 205. 205 is 1. There's 1, there's 0, there's 0, there's 1, there's 1, there's 0, there's 1. This 36 is 0, there's 0, there's 1, there's 0. Alright, so I'm going to put the answer first before I'm going to explain it. This 72 is 0 1 0 0 0 1 0 0 0. Then this 56 is equivalent to 0 dash 0 dash 1 dash 1 dash 1 dash 0 0 dash 0. Alright, so how it's possible? Just only add this 1 is 1 to 8 plus 64 plus 8 plus 4 plus 1 is equal to 205, and the other one is 32 plus 4 is 36. Then the last one is 56. We have 32 plus 16 is 48 plus 8 is 56. And therefore our answer number 9 is 1 1 0 0 1 1 0 1. Alright, 1 2 3 4 5 6 7 8, and then 36 is what? 0 0 1 0 0 1 0 0. Okay, 0 0 100 100, and then 72 is 0 1 0 0 1 0 0 0. Am I correct? right? It's 72. The other one is 56. We have 0, 0, 1, 1, 1, 0, 0, 0. Right? I'm going to add these 3 ones. This 32, 16, and 8 is equivalent to 56. And now, here. The number 1, so since the number 1 is in the prefix length. Alright, how we're going to calculate this prefix length? As you can see, that the prefix is when you're going to calculate this 1, 2, 3, this network and this host, this is the host and this is the network function. So we're going to calculate this 3 is 24. So since then we have borrowed from the host, it is 3. These are 3 numbers from the host, 3 bits from the host. This is equivalent to 27. So 24 plus 3 is equals to 27. So the answer for the number 1 is 27. And then for the number 2. For the number 2 is, as you can see, 192.168.10.0. So those, the last digit or the host function of the network address is this 255, which means it is the last digit of the if you're going to calculate all of these numbers, this 1, 2, 4, 8, 16, 32, 64, and 128, there is equivalence to 225. So as you can see, we're going to change the last or the host function of the network address into 255. So our answer would be 172.201.95.255. So number 2 is, the answer is 172.201.95.255. Alright. Then number 3. So here is the number 3. Yes, the number 3. Alright. So how it is possible? How we're going to get the correct answer for this? So what we're going to do is, the host, we're going to calculate the host function. So this 1286432168421 will be going to calculate. So if here's for example, so we have this is 225. We're going to calculate all, which is the default subnet mask, and we're going to find the host. So it is 128. So the answer would be 10.10.78. I'm sorry, the answer would be 255.255.255.128. So number 3 is 255.255.128. So how did I come up with that answer? So we're going to see this one. Right, so we're going to observe the other one. Here is for the example. So 192 is the last, or the host, the last digit. So if we're going to add this 2 last digit is 128 plus 64 is equivalent to 122. That's what I did in number 23. Then next one is this number 4. So as you can see, that the host function it only add 1. So in order to get the gateway address, so the network address is this the last digit of this network address, just add 1 to get the gateway address. Since we have this 10.10.78.128, so it will be going to 10.10.78.129. So number 4 is 10.10.78.129. Here's number 6. So what is the number 6? Here is the number 6. So as you can see, what I did on the second question, so just only get the network address and change the last digit into 255. So the answer would be 192.235.255. Alright, just put it in here. So 192.84.235.255. Okay, let's move to number 7. So number 7, that's what I did in number 1. So I only calculate these 2 bits from the host function. So 128. So yes, is 24. 8 plus 8 plus 8 is 24 plus 2 is 26. So therefore number 7's answer is 26. Then number 8, so same as number 2 and number 6, just copy the network address and change the last digit into 255. So the answer for number 8 is 172.99.184.255. So I'm going to put it to number 8. 172.99.184.255. Am I correct? Let's check. And right, 184. Here, the last one, which is number 10. Yes, number 10, same as what I did on number 8, is you only have to change the last digit of the network address into 255. So my answer would be 255.36.72.255. So I'm going to put it to number 10, right? 205.36.72.255. Check 256, 206, 205, 36.72, 205, 36.72, then that 55. And that is how I get the answers. Thank you for watching, and I hope you enjoy.